managed to look at various parts in this topic. One, we looked at the efficiency, we looked at the EMF of DC generator. We looked at the types of DC generator. We also looked at calculations involving various types of DC generators, like short shunt generator, short shunt wound generator, serial wound generator, and now we are looking at the efficiency of a DC generator. Remember we said that efficiency of a machine can never be 100%. This is because of the losses. There are some losses like frictional losses and ion losses and windage losses that occur as the machine rotates or it is in the motion. So we are going to look at our example one, and it says a 15 kilowatt shunt generator having an armature current circuit resistance of 0.4 ohms and a field resistance of 100 ohms generates a terminal voltage of 240 volts at full load. Determine the efficiency of the generator at full load, assuming the ion losses, friction losses, and windage losses amount to 1 kilowatt. So the question is requiring us to look for the efficiency of that generator at full load. Let's go straight to the solution. We can see that we are given, we have power, which is 15 kilowatts. And remember we said kilo means 1,000. We also have the armature resistance, RA. We have a field resistance of 100 ohms and the terminal voltage of 240 volts. And we have been told that the losses amount to 1 kilowatt. So let's look at the solution. We have already seen this, what we have in the question. We have the terminal voltage of 240 volts, the armature resistance of 0.4 ohms, field resistance of 100 ohms, and load of 15 kilowatts, and the losses we have been told they amount to 1 kilowatt. Now, the first thing or step one that we're supposed to look at to enable us to look for the efficiency, we cannot just go direct writing the formula and start calculating the efficiency. There are various steps or stages that we are supposed to look at for us to derive the efficiency of a DC generator at full load. So using the question, we can see we have to look at the load current because we have been given the output power, which is 15 kilowatt. And remember we have said that kilo means 1,000, so we shall have 15 multiplied by 1,000. And using power triangle, we know that power is given by voltage multiplied by current. We have seen that in our previous videos. Therefore, in this case, we are looking for current, and current will be given by power over voltage. And therefore, we have our output power, which is 15,000 watts, and our terminal voltage is 240 volts. So we shall have 15,000 divided by 240 volts, and therefore we shall get our load current is 62.5 amperes. Take your calculator and key in 15,000 divided by 240, and you shall get your current as your load current as 62.5 amperes. After getting the load current, So the next thing that we're going to look at is to find the, the field current. That is our step 2. So our field current will be given by the terminal voltage divided by the field resistance. Using Ohm's law, we know that current is given by voltage over resistance. Therefore, our therefore our field current will be 240 divided by 100. 240 divided by 100, and it will give us 2.4 amperes. Remember, we said that for us to get the armature current, it is given by the sum of the field current plus load current. And that one we saw in our previous video, that is video 4, that deals with calculation is involving short shunt wound generator. We said that armature current is given by the load current plus the field current. Our load current is 62.5 amperes and our field current is 2.4 amperes. So when you sum up these two, we shall get the armature current, which is 64.9 amperes. Now we are almost to the going to the final stage for calculating uh, efficiency. And now we know that efficiency is given by output power over input power multiplied by 100%. Efficiency is given by output power divided by input power multiplied by 100%. So our output power is VI all over input power plus the IA squared. Our input power is given by the output power plus the losses, which is VI plus I armature current squared multiplied by the resistance plus the field current multiplied by voltage plus the losses. So we have said that, or we have seen that efficiency is given by the output power plus the input power plus losses. Input power is for us to get the input power, we have to look at the initial power that was in plus the losses for us to get the sum of input power. So our our output power, we have seen that it is 15,000 or 15 multiplied by 1,000 divided by the output power plus input power plus losses. The output power plus losses for us to get the input power. So we have 15,000 divided by 15,000 plus 64.9 squared multiplied by 0.4 plus 2.4 multiplied by 240 plus the losses, which we were told it's 1,000, sorry. So when you take your calculator and key in all those values, you shall get 0.82143 multiplied by 100%, and our efficiency will be equal to 82.143%. Our efficiency will be equal to 82.143%. percent. So kindly memorize on this formula on how to get efficiency. And we have seen that efficiency is given by the input output power over input power. And for us to get the input power, you have to add the output power plus losses. You have to get the output power plus losses for us to get the initial power, which is the input power. So that's it. I believe it is clear for you. We have an exercise for you here to make practice. And it says a 10 kilowatt shunt generator having an armature circuit resistance of 0.7 ohms and a field resistance of 125 ohms generates a terminal voltage of 250 volts at full load. Determine the efficiency at full load, assuming the iron losses, friction losses, and windage losses amount to 600 watts. This exercise it has no much difference from what we have done in the previous example. Just follow the steps closely, and I know you will be in a position to calculate or to solve this problem. Thank you for watching this